Hi there, this is Mr. Sand, and I just wanted to take you through the instructions for the Amazon Incline lab, the iLab. You might have seen a slightly different instruction screen if you clicked on this anytime before, what day is it today? The 17th, Wednesday 17th. Um, I've changed it slightly. I made it slightly easier. I forgot that I included an extra requirement on there before, so it might have seemed confusing. I was going to have an extra kind of examination attached to this, but I decided against that. I don't think it's necessary. I think this lab is perfectly fine how it is. So, what you need to do in this is, well, first read this. He says you'll now use a simulator to investigate variables that affect motion along a ramp. You'll record data, write a lab report, and present this data to your fellow classmates. The presentation will be recorded as a video, so you'll be recording some sort of a video. Here's the lab instructions. These are now updated. These were a little bit out of date. I'm sorry about that again. Everything's the same up to this point right here, and I'm going to first talk about this, and then I'm going to go through it in this simulator here. So, what this all says here is that you're going to take 5 minutes to play around with the simulation. So you just honestly just play around with the simulation. Treat it as your first run and think of the variables you'd like to manipulate. There's tons of variables to manipulate here, and it's a little overwhelming just to first look at it. So you go to this, you download this program. If you're on a Mac, you might need to go to your system preferences and go to your, I'll show you right here, go to your security and privacy section. And then when you first try to download this, it'll ask you at this point if it's okay to still run the program, and you say okay, and you can run the program. So that's that. Okay. If you have any problems with that, just let me know and I can help you as much as I can from my end. So it says here to click the friction tab. I'll pull up the simulation here. Where is it? It's right here. Here it is. Okay. So the introduction looks like this. Maybe you have different objects. Small crate, large crate. You might notice that there's this person that pushes on this object. And you can kind of go up and down with this. Change your ramp angle. Change this to bouncy. So now if it goes over here, it'll bounce. Oh. Okay. You can change the friction. So this is now ice, and so there's no friction. You can change all sorts of things, and this will just go on forever. You can change all sorts of things here. You can change the object, which will have a different mass and a different coefficient of kinetic friction and static friction. But here there's no friction, so let's put it back to wood. So there it stopped. You can show all the vectors if you want to. You can take the vectors off if you find that kind of annoying. What else can you do? Oh, change the ramp right here. I'm going to take off the bounce, and I'm going to turn on the sound effects. You can record this, you can play it back if you want to, but I said to go to the friction tab right here. And when you're playing around with this, notice that you can change all sorts of variables. You can change the static friction to very low or very high. You can change it higher here. Now I'm going to change it higher there, and notice that it stopped. You can change a ramp angle. You can change, I'll change a ramp angle on this little slider on the side instead of manually like this, because this gets you a little bit better. You can also put in the degrees right here that you want to change this ramp angle to, which is pretty cool. I'm going to get back to the object position, but you can change the position of the object like this instead of having a person push it. The walls really aren't that much of a factor, but if you want to try to make it a factor, go ahead. It'll be very creative. The friction, you can change it to no friction if you want to. You can do all of these sorts of things. The gravity is pretty cool. You can change the gravity on here. If there's less gravity, how does that affect things? All these variables are really cool. What I suggest you do for the lab now is just to ignore this person. Ignore the applied force. Don't give any applied force. That's my suggestion, is not to give any applied force in this situation. It makes things much more complicated. Instead, treat this as a ramp where you have to ship this box down the ramp. Okay? So ignore this person, and instead, when you're using, like for your lab, for your experiment, just position the box at some position on this ramp. Maybe this is the variable that you choose to manipulate. Okay, here's a whole bunch of variables that you can manipulate. Static friction, you can manipulate the kinetic friction, you can manipulate the mass, you can manipulate the gravity. All of this stuff you can manipulate. You can also manipulate the ramp angle if you like to as well. But I suggest what you do for every single time you start. I can also do this and make the position out to 10. Makes it a little bit more clean. What I suggest you do is you just always start at the same position, the object position, and you manipulate some variable over here to get some sort of a result. You can maybe the angle is what you manipulate. Maybe this is what you manipulate. Maybe the static friction is what you manipulate. So you decrease it here. Maybe what you do is you manipulate the kinetic friction, or the mass, or the gravity. All these are the things that you can manipulate. I'm not going to tell you which one you should or should not do. Think about what you would like to manipulate. For the lab, then you need to have some sort of an effect. So one effect could be that if you started off the same position every single time and you manipulate the static friction, it will change the final position, because you can see what the final position is right here, over here. You can also see it kind of not in a digital kind of way, in an analog way over here. So I suggest using this little right here, this little kind of readout as your effect. So that's one way you can measure the effect. Another way you can measure the effect is, let's say, oh, I don't want to use that person. Let's say that you start up here, and I don't know, your variable is ramp angle. So if you start at 10, at what point does the effect would be, like if you change the static friction right here, static friction coefficient, at what point does, that should not be moving, sorry. At what point does, that's weird that it jumps right there. So that's a little glitch in the software. So it starts at 8.9 there. Okay, at what point does this box start moving? So you increase this slowly and see what point does that box start moving. And that is, the angle is then your effect, where it starts moving. And it should be any point, there it goes. It starts moving at 24.3 degrees. Okay, so now if you increase this static friction right here, you probably would think that if you go then back down to 0 and move this back out to 10, which we now know that is, it goes to 8.9 for some reason. So when you go up to 23, you'd guess that it goes a little bit higher. And let's see if it happens. Now it's already a little bit higher. You go a little bit higher, go a little bit higher, go a little bit higher, go even a little bit higher. It should be going any minute. Oh, there it goes, 28. Probably it was about 28.3. I think I went over a little bit there. So that changed the ramp angle. So the effect was a ramp angle at which it started to move, and the independent variable was the static friction there. You can change the kinetic friction, you can change the mass, you can change the gravity. All those things are different variables you can change, and at the point at which it starts moving, that can be your effect. Another thing that people like to use for their effect when they're measuring this is, let's say that we have this right here. Another thing is that they like to change is their speed at which, or the time at which it takes for the object to go from the top of the ramp to the bottom of the ramp. So they use like a stopwatch that's separate from this program. So you've got your little stopwatch on your iPhone, and you're saying, okay, when I release this, how long does it take for it to go down all the way to the bottom of the ramp? Okay, so I say 3, 2, 1, and I'd start my watch, and then when it gets to the bottom, I'd say stop, and then that's the time it takes for the box to get down to the bottom of the ramp. Okay, so those are 3 ways you can measure the effects of your variables. One of them is the time it takes to go down the ramp. The other one is how far it goes from the initial position. And you can see where the final position is here. And the initial position was 10. Another effect you can measure is that the angle at which the object starts to move. So those are 3 ways you can measure any of these variables. I think that gives you plenty of options here to play around with these variables, but it also gives you some kind of direction. In class, I would just have people play around with this until they figure out what the effects are and what the variables are, but it's not all that clear without having a teacher in the room. So those are some hints and some tips in how you're going to set up this lab. Yeah, so good luck. If you want to do any other kinds of changes to this and you're not quite sure if this is going to be possible, just go ahead, email me, and I can answer that question. Okay, good luck. Bye.